Hello and welcome to 8.4 Notes. So in previous lessons we went over the concept of parallelograms, what a parallelogram is, and what the properties of parallelograms are. Well, today we're going to go over three specific kinds or three specific special types of parallelograms, and those are rhombuses, rectangles, and squares. So let's hit some definitions first. So a rhombus is defined as a parallelogram with four congruent sides. So that would be a rhombus. Notice that it is a parallelogram and it has four congruent sides. Notice that it doesn't speak at all to the angles, so we don't know what the angular measurements are. If the angles were four right angles, along with the four congruent sides, then we'd have a square, right? But we don't know anything about the angles, so it's not necessarily a square. It's sort of this diamond-shaped thing. It's a rhombus, okay? A parallelogram with four congruent sides. A rectangle is defined as a parallelogram with four congruent angles. So if we know that we have four 90-degree angles, and notice that the pairs of opposite sides are not congruent to each other. If they were, then it would be a square. Then we have a rectangle. So a rectangle is a parallelogram with four congruent angles, or four right angles, or four 90-degree angles. And then a square is defined as a parallelogram with four congruent sides and four right angles. So it's both a rhombus and a rectangle. So there we have a square. It has four congruent sides and four 90-degree angles, or four right angles. So next up, we have some corollaries that we can use to prove that a quadrilateral is either a rhombus, a rectangle, or a square without first having to prove that the quadrilateral is a parallelogram. So here are some useful corollaries. The first corollary is a quadrilateral is a rhombus if and only if it has four congruent sides. So ABCD is a rhombus if and only if AB is congruent to BC, is congruent to CD, is congruent to AD. That's a rhombus. Next up, we have the rectangle corollary, which states that a quadrilateral is a rectangle if and only if it has four right angles. So ABCD is a rectangle if and only if angle angle A, angle B, angle C, and angle D are right angles. Okay? If you have four 90-degree angles in a quadrilateral, then you have a rectangle. Okay? That's all you need to prove. And a quadrilateral is a square if and only if it is both a rhombus and a rectangle. So in this case, ABCD is a square if and only if AB is congruent to BC, is congruent to CD, is congruent to AD, and also angle A, angle B, angle C, and angle D are right angles or 90-degree angles. In that case, you have a square. So those are your corollaries that you will use. If I went a bit too fast in this presentation, then you can pause this video at any time you'd like and copy down the notes and go back and review anything you might have missed. Remember, you're always in total control of these presentations. Okay? So before we continue, I just wanted to mention that if you were in class for this lesson, then at this point we took a break from the notes and I had you do some activities in class, right? We classified special quadrilaterals, we identified special quadrilaterals, and I had you make a Venn diagram of these special quadrilaterals in which I had you construct rhombuses, squares, and rectangles within the Venn diagram in the proper place. So we had these activities, right, making Venn diagrams and classifying and identifying. But for this YouTube presentation, I didn't think that this presentation would be conducive to having these activities. So I've decided not to try to construct them because I kind of need to be there with you to do that. So I've decided to just present the corollaries in this YouTube presentation, and following now we're going to do some theorems. But I just want to mention that because I think, class was a little bit more active, a little bit more dynamic, a little bit more fun, frankly, because we broke at this point and had some engaging activities, which, like I say, I can't really present in this YouTube presentation. So for the sake of this YouTube lecture, I'll just move right along with some theorems. So the first theorem is that a parallelogram is a rhombus if and only if its diagonals are perpendicular. So in this case, parallelogram ABCD is a rhombus if and only if AC, what's happening here? Oh, there you go. Oh, if and only if line segment AC is perpendicular to line segment BD. So if the diagonals are perpendicular, then you have a rhombus. That parallelogram is a rhombus. Okay? And then the next theorem is a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So in this case, ABCD is a rhombus if and only if line segment AC bisects angle BCD and BAD, and line segment BD bisects angle ABC and angle ADC. So in this case, for example, line segment AC, so this line segment here, bisects angle BCD, so it takes this angle and it bisects it and cuts it in half. That's why you have those tick marks there. And BAD, so the same with this angle here, and it bisects that. So they're all congruent. Okay, and also line segment BD has to do the same with angle ABC and angle ADC. It has to bisect those angles. So if it does that, if each diagonal bisects a pair of opposite angles, then that parallelogram is a rhombus. Okay? And then lastly, we have a parallelogram is a rectangle if and only if its diagonals are congruent. So in this case, parallelogram ABCD is a rectangle if and only if line segment AC is congruent with line segment BD. In other words, if the diagonals are congruent. Okay? And like I said, class for this lesson was a bit more dynamic because we had activities and things to do, but like I said, I really don't know how to interpret that for this YouTube presentation. I think you have to be in class for that, frankly, and there has to be a physical teacher present during this process. But anyway, so we've gone over the basic corollaries and theorems, and hopefully you're gaining an understanding of the properties of rhombuses, rectangles, and squares. If you feel that you've missed anything, like in terms of the activities or anything, or if you want to go over any of this, or you have any questions regarding this lesson, please feel free to contact me at your convenience, and it would be my pleasure to help you. Okay? Bye-bye.